Y is the transmission line 11 kilovolt, 33 kilovolt, 66. Not is 10, 20, 30, 40 or whatever. So choice of the transmission line voltages such as 11 kilovolt, 11 kilovolt, 33 kilovolt and 66 kilovolt instead of the 10, 20 and 30 involves a combination of technical, economic and practical considerations. These voltage levels are not arbitrary and they are determined through a comprehensive analysis to optimize the efficiency, cost effectiveness and reliability of the power transmission system. Let us delve into the deeper region behind these choices. First one, voltage regulation. First one, voltage voltage regulation and losses. One of the main concerns in the power transmission in minimizing the transmission losses and ensuring the voltage regulation. Voltage drop along the transmission line leads to the power losses and reduced efficiency. By choosing the voltages like 11 kilovolt, 33 kilovolt and 66 kilovolt, engineers can believe the trade-off between the acceptable transmission losses and voltage drop. These voltages provide a good compromise between the minimizing losses and maintaining a reasonable voltage profile. Second one is the equipment considerations. Equipment considerations. The choice of voltage impacts the design and selection of voltage transmission line concepts such as transformers, insulators, circuit breakers, and switchgear. The availability and the cost of these components at the specific voltage levels play a role in determining the most suitable voltage for a given transmission system. Third one is the standardization. Third one is the standardization. The voltage level used in the upper power transmission have been standardized over the time to ensure the interoperability, compatibility, and safety across different systems and countries. These standardization facilitates the exchange of power between the utilities and the promotes a unified approach to the power transmission infrastructure. Fourth one is the economic factors. The cost of constructing and maintaining the power transmission line is significant considerations. Higher voltage can allow for the longer transmission distance with few losses, reducing the need of the additional infrastructure. However, higher voltage also require more insulation and safety precautions, potentially offsetting some of these benefits. Safety and insulation. Insulation requirements increase with the voltage levels to prevent electrical breakdown and ensure the public safety. Insulating material capable of withstanding higher voltages tend to be a bulkier and more expensive. By choosing the voltages that are slightly higher, engineers can achieve the better safety margins while still maintaining the cost effectiveness. Next one is the practical constraints. The existing infrastructure, terrain, and geographical constraints of a region can influence the choice of choice of transmission voltage. In some cases, it might be practical to step up or down from the certain voltage levels based on the availability of the substations and other facilities. Next one is the load demand, 671. The voltage level also need to match the load demand of the region. The chosen voltage should be able to supply the required power without overloading the system. These decisions are often based on the projected growth in demand over the year. Last one is the international standards. International organizations such as the International Electro Technical Commission (IEC) and regional bodies like the North American Electric Reliability Corporation (NERC) provide the guidelines and the standards for the power transmission voltage. These organizations consider electrical, technical, safety, and compatibility factors when setting these standards. In conclusion, we can say that the selection of the transmission line voltage voltages involves a complex interplay of the technical, economic, safety, and practical factors. The voltages like the 11 kilovolt, 33 kilovolt, and 66 kilovolt are a result of the careful optimization to strike a balance between the efficiency, cost safety, and compatibility within the broader context of